So the halogen alkane, we were discussing the reaction mechanism of halogen alkane. When we add potassium hydroxide or sodium hydroxide in aqueous medium, it undergo a nucleophilic substitution reaction, and that substitution depends on the type of halogen alkane. If we have primary, it will undergo SN2 reaction mechanism, and if it is secondary, tertiary, then it will be SN1. Another nucleophilic reaction is with reaction with ammonia. So when these halogen alkane they react with ammonia, so again this will be a nucleophilic substitution reaction, but how the reaction proceed if you want to complete. So this is a halogen alkane, we add ammonia. This is the overall reaction. It will result in a formation of amine. So because in NH3, when we have NH3, NH2 is partial negative and hydrogen is partial positive. So this NH2 will take position of the bromide like bromine here, which is partial negative. As a result, it produces an amine and ammonia bromide. How we carry out this reaction? So if we want to convert the halogen alkane into amine, we use a reagent ammonia dissolved in ethanol, and we heat under the pressure like in a sealed tube, and as a mechanism there will be a nucleophilic substitution reaction and multiple substitution will occur. If we have a limited supply of ammonia, like a small quantity, or if ammonia is a limiting reagent, then multiple substitution might occur. If we have excess of ammonia, then there will be single substitution occur and more of the ammonia molecule will react. So how the reaction proceed, like example, the idea is the same, like it's a nucleophilic substitution reaction, primary, secondary, or third, it can be SN2 or it can be SN1 depending on which halogen alkane we have. So example, if we have a primary halogen alkane, so carbon here is partial positive, bromine is partial negative, and ammonia is NH3. So it's nitrogen is forming a 3 bonds with hydrogen, and there is a lone pair on nitrogen. So this lone pair is actually attracted towards the electron deficient side or the partial positive carbon. So when this lone pair is attracted towards the carbon, the bromine will try to break the bond. So, and this is because it's a primary halogen alkane, so bond breaking and bond forming will take place at the same time. So NH3 will try to form a bond with carbon, and bromine will try to break the bond. So bond breaking and bond forming take place at the same time. So now bromine is being removed and NH3 is attached. Then there will be another molecule of ammonia with a lone pair, and that will attract the hydrogen, that will try to form a bond with hydrogen, a dative bond. So it will form ammonium ion, and this electron which is involved in the bonding is taken by the nitrogen. So this charge will be removed from nitrogen and we will get the overall product. I will show how this reaction proceed. Look, first what we have, we can have primary halogen alkane, and it can be any primary halogen alkane. For example, this is a primary halogen alkane. X means it can be any halogen. It can be primary, secondary, or tertiary. The reaction mechanism, only SN1 or SN2 will change, but the overall mechanism will be same, the manner in which they react. So it is important that you mention partial positive and negative. Carbon is partial positive and the halogen is partial negative because it is more electronegative. Then we have an attacking nucleophile, which is ammonia NH3, which contain a lone pair. So this lone pair, nucleophile means these are species which are having a lone pair or a negative charge, so they're attracted toward the positive center. So they're attracted towards the carbon, positive, partial positive, and chlorine will try to break the bond. The halogen will try to break the bond. So as a result, what will happen? Now nitrogen maximum can form 3 bond, but now it form 4 bond because the nitrogen transfer the electron to carbon as a carbon lost electron to halogen. So this nitrogen is having 3 hydrogen, 1, 2 and 3. So if I draw the lone pair on the right hand side, so it will be easy to understand. So this is attracted towards the carbon. So as a result, what happened? This nitrogen will form the fourth bond with the carbon. And how it form a fourth bond? Because nitrogen belongs to group 5. As it belongs to group 5, it is having 5 electron. But as the nitrogen lose one of the electron to carbon, so now the nitrogen is having a positive charge and 4 electrons as it lost one of the electron to the carbon. So 4 electron and there will be a positive charge, so that's why it can form now 4 bonds. So initially it form a 4 bonds. So when it is forming a 4 bond, now there will be a positive charge on nitrogen, and this is the carbon 1 2, like 1 2 3 and 4, and the halogen left, so there will be a negative charge on the halogen. Then what happened? Another ammonia molecule so another ammonia molecule will attract the hydrogen or try to form a bond with hydrogen. So as a result, one of the hydrogen is being removed. So when that hydrogen is removed, now the nitrogen will have 3 bonds. And when it is having 3 bonds, now it is stable and there is no charge on nitrogen now as it take that electron back from the hydrogen. So there are 2 bonds and then this is CH3 H plus that now become NH4 because it took one of the hydrogen, so it will become NH4, and that halogen which is removed, so it will combine with NH4 or ammonium, so it will form ammonium halide. So this is how this reaction proceed when it is reacting with ammonia in ethanol. Because the reason why we are carrying out this reaction in ethanol, halogen alkanes are not water soluble. Why they are not water soluble? They cannot form a hydrogen bond. So as they are not able to form the hydrogen bond, that's why they are not water soluble until unless fluorine is there, but they're not able to form a hydrogen bond. That's why we mix them in ethanol under a high pressure and under reflux in a sealed container so that substitution reaction can occur. If we This is what happen if we have excess means more ammonia, excess of ammonia, multiple substitution does not occur. But if we have a limited supply of ammonia, like ammonia is not too much, then what happen? If I generally write the equation like CH3 is there and halogen reacted with ammonia, so which contain NH2 and H. This is partial negative, partial positive, partial negative, partial positive. So this NH2 will take position of the halogen. As a result, what it produce? It will produce CH3 NH2 plus HX. Then what happen if we have limited supply of ammonia? Then there is no more ammonia available. So as a result, the halogen alkane molecules further reacted with amine Now this is CH3, NH, and then H, because NH2 means NH in H. So this will be partial negative, this will be partial positive, partial negative, positive. So this whole partial negative part will take position of halogen. As a result, what happened? It will be CH3, CH3 will be there, and H will be there, plus HX. And then this is partial negative, this is partial positive. So this will further react with halogen alkane, because we have more halogen alkane. So the reaction will continue until all of the hydrogen are replaced by, so there will be a partial negative on nitrogen and partial positive on hydrogen, and partial negative and positive. So this whole negative part, this whole is a negative part, that will be replaced by halogen. So as a result, it will produce CH3, N, CH3 and CH3 plus HX. So this is, multiple substitution will occur when we have limited ammonia or small quantity of ammonia. And if we have excess of ammonia, like more than enough ammonia, then multiple substitution does not occur. The reaction will continue as all of the halogen alkane convert into amines. Is it clear, this reaction mechanism for conversion of halogen alkane into amine? Any doubt till this point? Then the second type of reaction is elimination reaction. Elimination means when elements, atoms or group of atoms are removed from the molecule, we call elimination. So elimination reaction occur when we are using alcoholic potassium hydroxide. If we are using aqueous potassium hydroxide, then it will be substitution reaction, but in alcoholic, it will be elimination reaction. And whenever elimination reaction occur, this will result in a formation of alkene. So if we have halogen alkane, example, this is a halogen alkane. Say bromine is attached. This is having 3 hydrogen. And we add KOH, alcoholic medium. Then there are two possibilities. Basically, what happened in elimination, the halogen alkane is removed, and the next carbon on the left or the right hand side, one of the hydrogen is removed. So either it can be removed from this one or it can be removed from this one, because either from left or right, one of the hydrogen is removed. So if the hydrogen from the left hand side is removed, like one H is removed, another one Br is removed, so as a result, what will form? There will be two hydrogen atoms, and this H is removed and Br is removed, so it will form bond here, And this HBr, which is removed here, will react with KOH. So when HBr is mixed with KOH, so HBr acidic, KOH is a base. So acid plus base gives salt and water. So as a result, what they will produce? They will produce KBr, the salt, potassium bromide, and H2O, the water. This is when we are using KOH in alcoholic medium. Same thing, if you are using KOH in alcoholic medium, what could be the second possibility? That the second and the, because possibility is there, the halogen alkane will be removed, like halogen will be removed, but the adjacent carbon either on the left or the right hand side, that will lose its hydrogen. So as a result, if the left hand side is losing the hydrogen, the double bond is there between first and second. If the hydrogen is removed from the right hand side, then the double bond is there between second and third. So this will be CH3. This will be CH. Bromine is removed. And now this hydrogen is being removed. So what is the possibility? There will be a double bond here and CH3. And again H and Br, which H and Br, HBr is removed, reacted with KOH. So as a result, it will produce potassium bromide plus water. So both possibilities are there. If we have asymmetrical halogen alkane, like halogen alkane is not having a symmetry, then it can lose hydrogen from the left or the right hand side. But if it is a symmetrical, then or identical, then it will lose only from one side. It won't make difference. But this one is not a symmetrical halogen alkane, because the carbon which is attached with the carbon here, which is attached with halogen, one side it is having two carbon, another side it is having only one carbon. And this reaction is known as elimination reaction. So it is very important that you learn the conditions. If we have potassium hydroxide, so as we know, potassium hydroxide is there in aqueous medium, it will undergo a substitution reaction. But if we have potassium hydroxide with in alcoholic medium, then what will happen? The one which is it will undergo an elimination reaction, or as a result it will produce an alkene. Is it clear? Any doubt? Then the uses of the halogen alkane, this is the same thing. If you have unsymmetrical halogen alkane, then this might result in a formation of different types of alkene. The uses of halogen alkane, they are used as refrigerant, fire retardant, pesticides, aerosol propellant. What is the reason? Because uh, refrigerant gas, it has a tendency, like these halogen alkanes are gases, and they have a greater tendency to absorb the heat energy. That's why we are using as a refrigerant gas. Fire retardant, because they are not flammable or low flammability, that's why they are used as in a fire retardant, or we are also using as an aerosol propellant gas, as it does not catch fire. Then when we compare the rate of hydrolysis, the term hydrolysis means when we break down the molecule by the help of water, we call hydrolysis. So when we compare the rate of hydrolysis of alkyl halides, like example, which contain iodine or contain bromine or contain chlorine. So we find that the alkyl halides which contain iodine, they break down faster as compared to alkyl halides which contain chlorine. What is the reason for that? The reason, because the iodine is larger in size, so the bond length is longer and the bond energy is weaker, like smaller amount of energy is needed to break the bond. So when we hydrolyze them, how to write the equation for hydrolysis? Like we have halogen alkane and we react with water. Water means H2O or H and OH we can also say. So this is partial negative, partial positive, partial negative, partial positive. So this OH will take position, it will produce an alcohol and it produce hydrogen halide. And this hydrogen halide, what we do, we can mix with silver nitrate. As a result, it will produce precipitate. If it is a iodide precipitate like silver iodide, it will be yellow. Silver bromide, it will be cream, and silver chloride, it will be white. So we will find that the quicker the precipitate form, the faster the substitution or more reactive the halogen. So the rate of substitution depends on strength of the carbon and halogen bond, and weaker bonds are easy to break. That's why when we compare silver iodide, it break down faster, like it form faster as compared to silver bromide, and it form faster than silver chloride. So what is the main reason for that? It's about the bond length and the bond energy. So example, if we have carbon bonded with iodine, carbon bonded with bromine, and carbon bonded with chlorine. Because iodine is much larger in size, so it is a weaker bond. And when you check the bond energy, the table here shows the bond energy. As you can see, carbon and iodine, it is 238 kilojoule per mole. Carbon bromine 276. Carbon chlorine 338. So means this bond is easy to break or smaller amount of energy is needed. This bond carbon and chlorine is difficult to break or it will take time to break this bond. So when we react them with water first, because hydrolysis means breakdown by the help of water molecule. So as a result, this will produce, because this is partial, I'm not drawing the all the bonds, I'm just generally showing how this can happen. So this OH will take position of iodine, this OH will take position of bromine, but which case it can displace it faster. So example, it took 10 seconds for this one, this will 15 seconds, and this will take 20 seconds. And why? What is the reason for that? Because iodine, this is longer bond length or weaker, and means longer bond length or smaller amount of energy needed to break the bond. So this will produce COH, means alcohol will be there, and hydrogen halide. And this will produce COH and hydrogen halide, which is bromide in this case. And this will also produce COH and this hydrogen chloride. And this hydrogen chloride, because if we add silver nitrate AgNO3, or we add AgNO3 to HBr, or we add silver nitrate to HCl, as a result what happened, it will produce silver iodide. This will produce silver bromide, and this will produce silver chloride. So this will result in a formation of a yellow precipitate. This will form a cream color precipitate, and this will give a white PPT. So we can identify color of the precipitate shows which halide is present, and the time it take to break down shows that which one is there, like the halide contain chloride, bromide, or iodide. So hydrolysis is a breakdown of the molecule by the help of water. So this was a topic about alcohols and halogen alkanes. The next session we will discuss the topic wise question related to alcohols and halogen alkane. Any question or a doubt related to the class?